Hello and welcome everybody. This is Noah, and in this video we're going to look at some graphs of some relationships between x and y values, and we're going to determine if those relationships constitute a function or not. So we've done this with some sets of points and some tables. We've actually done it in like the inverse direction, like is x a function of y or is y a function of x. In this video we're only going to look and determine if y is a function of x. If we think of x as the inputs and y as the outputs, does this graph constitute a function? So let's take a look at these three examples for this. This should go pretty quick. We've got three different graphs, and we want to say which of these constitute a function, and we're going to state the domain and range of each. So the first graph is made up of just a bunch of points. It looks like we have 7 points here. The first point is down at -5, -4. We've got another point at -3, -2. We've got a point at -3, +1. We have a point at 0, 3. We have a point at 2, 3. We have a point at 3, 3. And we have a point at 4, 0. So if I look at these, what I hone in on here is that the points -3, -2, and -3, +1, this is saying if x equals -3, we output, this relationship outputs 1 and -2. So this is not a function. Right? The other inputs that we have, -5 only outputs -4, 0 only outputs 3, 2 only outputs 3, 3 only outputs 3, and 4 only outputs 0, but -3 has two different outputs, so this is not a function. We can state its domain and range. Let's get in here. That's okay. I'll squeeze it in. The domain, actually, I'm just going to pause this and fix it. All right, there we go. The domain is all of the x values. We have -5, -3, which we saw had two outputs. Then we have an input of 0, an input of 2, an input of 3, and an input of 4. The possible outputs are the range. So the range equals the set including -4 we could get out -2, we could get out 0, we could get out +1, and we can get out 3. And that's it for all of the possible outputs. As we look through those points, I'm just looking for all of the different y values I could get and listing those for the range. All right, hopefully that's not too bad. Let's take a look at part B, where we have the graph of an oval. The oval has a center of 2, 1. Technically, this is an ellipse. It has vertices at, well, we've got a vertex. The top vertex is at 2, 3. The right vertex is at 5, 1. The bottom vertex is at 2, -1. And the leftmost vertex is -1, 1. So it's just a stretched circle. It's a little bit wider than it is tall. All right, so we're going to take a look at this and determine if this constitutes a function or not. And if I look at any x value, if I take if x is 0, then the graph has two different points when x is 0. We have the point 0, about -0.4, and we have the point 0, 2.4. If x is 2, we see that the graph has two outputs, both 3 and -1. If x was 3.5, there are two different points with that x value on this oval. we have like 3.5, comma 2.8, and 3.5, comma negative 0.8. And this continues for all of the x values between negative 1 and 5. So if I look at the vertice on the left, negative 1, 1, and the vertice on the right, 5, comma 1, those inputs of negative 1, the input of negative 1 only outputs 1. The input of 5 only outputs 1 as its y value. But all the inputs between negative 1 and positive 5 have two different outputs, two different points on that oval for y values for that given x value. So this is not a function. And so even though I only showed these three examples, really I could have picked any x value between negative 1 and 5 and shown that it has two different outputs. So every x value between negative 1 and 5 has 2 points on the ellipse so 2 outputs for each of these inputs. And hence, this is not a function. All right, we do want to look at the domain and range here. Let's note that the domain is all of the, like this ellipse goes, its leftmost endpoint is negative 1, its rightmost endpoint is 5, and it does have points on it between, for all of the x values in between there. So the domain, we're going to use interval notation and say from negative 1 to 5 is the domain using hard brackets, square brackets on the ends to say that we're including negative 1 and positive 5 for that domain. The range is all the possible outputs for this relationship. This is a good relationship. It's an oval, and we can talk about how x and y relate to each other on this picture, on this graph. It's just not considered a function. The range is all the possible y values we can get on this graph. The lowest y value is negative 1 at the bottom vertice. The highest y value is positive 3, which we get at the top vertice. And we do see that as we travel around the ellipse, we get all of the y values in between those two y values. So the range goes from negative 1 at the bottom to positive 3 at the top. We'll use square brackets again because we do get those two y values here. And that will wrap up the range for this function. Or, I'm sorry, the range for this relationship is not a function. And that's everything we're doing for this problem. Let's go ahead and move on to part C. Pause the video if you need to. Go on to part C, and this is a graph of, well, this is a polynomial function. There's a good chance you haven't seen a function that looks quite like this, but it's just a squiggly line. It starts in the top left, it comes down, and then it comes up, and then down, and then up, and then down again, and then it keeps going down for forever. It never cycles back left and right on itself. It's always just like as we move left to right, it just goes down, then up, and down, then up, and down. As I move along it from left to right, for any x value that I look at, there's only a single point on the line. If I look at x is negative 2, we have the point negative 2, 2. If I looked at x is negative 1.4, we can go down to the bottom and see that we have a y value of about negative 1.1, give or take. And as we keep doing this, as I keep looking at x values, different x values, I see that the line will only take on one y value. If I pick an x value, I won't find 2 points above each other, indicating that there's two different outputs for that x value. So as we move left to right, different x values, there's always, no matter where I look, I'm never going to find a location where there's two y values for a single x value on the graph itself. So yes, this graph is a function. Each point on it, each x value in its domain only has one point on the graph, so only a single y value output for each x value input. Now, as we look at this graph and we want to talk about its domain and range, the arrows seem to be going up, but they're also slightly, to the left. It's more up than left, and the bottom right arrow is definitely pointing more down than right, but they are, the left arrow is pointing to the left a bit, and the right arrow is pointing to the right a bit. It is indicating that this does keep moving to the left for forever and to the right for forever. So the domain is the set of all real numbers, or the interval from negative infinity to infinity. Either notation's fine here. And we also note, as I say that there's no x values that are skipped, right? This line doesn't have any breaks or jumps in it at any location. Now the range is the set of all possible outputs, y values. And if I took this graph and I smashed it onto the y-axis to think about what is the range, well, the entire y-axis would be included. Nothing would be skipped, right? There would be some parts that get smashed onto the y-axis twice where there would be like some layers there, right? But no y value is skipped, and that's the key thing here. So the range is the set of all real numbers, negative infinity to positive infinity as well. All right, there we go. Kind of summing up all of those graphs. Rewind, pause, make sure you've got your head kind of wrapped around that, and then give the Now You Try problems a go. And in the next video, I'll walk through those solutions. Thanks. See you in a bit.